Now to problem number 70 of NSCP 2019-20. In this problem, there are two long straight current carrying wires through which equal current flows, and that flows in opposite direction. Now because the current is flowing in opposite direction, so the wires should repel each other. Here is a diagram, and you can see these are the two wires in which equal current I is flowing in opposite direction. So they're repelling each other. These wires, they're suspended from a fixed rod PQ. So here is a fixed rod PQ, which is used to suspend these two wires with the help of four strings: 1, 2, 3, and 4. And the length of each string is equals to L, as you can see in the diagram. The mass per unit length of each wire is lambda. And we are supposed to find the angle between the length OA and OB. Let's try to attempt this problem. So here is a diagram. If we rotate this by 90 degrees, this is how it should look like. In this diagram, this rod is represented by a small circle and through which current is flowing into the paper. And the other rod is represented by this small circle, and the current is coming normally outside. Let us try to focus this rod. The various forces acting on it, this got to be its weight mg. The force of repulsion between the two is F, and there will be tension. There is tension in the rod which acts in this direction. Let's assume this angle to be alpha. If this is alpha, this angle also got to be alpha. From the diagram, we can say that tan of alpha, this got to be equals to F by mg. Let's try to put values. The value of F is equals to mu naught I1 into I2 by 2 pi d. D is the separation between the two rods, into L. L is the length of this rod upon mg. Because the mass per unit length of this rod is lambda, so this m can be replaced by lambda L. Angle between OA and OC is theta, which is small, and hence alpha should also be small. So this equation, tan alpha, can always be written as a small alpha. So we are left with mu naught I square upon 2 pi lambda d into g. This implies that theta by 2 equals to mu naught I square upon 2 pi lambda. Now you see this d, this separation d, can always be rewritten as equals to L into theta. So this is equals to L into theta times g. 2 and 2 will cancel. This theta can be brought on the left side, and hence theta square is equals to mu naught I square upon pi lambda L into g. And this further implies theta is equals to I multiplied by square root of mu naught upon pi lambda L into g. If you look at the various available options, then option B seems to be correct. Thank you.